All right, welcome back to Notes 10-1, Part 2. So I asked you to go ahead and try to simplify each of these and state any restrictions. And so for the first one, A, I'll go ahead and do those with you. For the try these, A, and this is A. All right, we have x squared plus 20x plus 36 over x cubed minus 4x. So remember, step one is to figure out what the restrictions on the domain are. So we're going to set the denominator equal to 0 and then factor. So x cubed minus 4x cannot equal 0. Always when you're factoring, you should check for a GCF first. I see there is a GCF. They have a GCF of x in common, right? So I'm going to take the x out. That gives me x squared minus 4 cannot equal 0. All right, and then this is a difference of perfect squares, and so that factors as x plus 2, x minus 2, and then don't forget to bring down your x. And now we're going to apply the zero product property. And so the zero product property is, again, so we set denominator not equal to 0, and then factor, and then the zero product property. And so we're going to take each of these three factors. We're going to say none of them can equal 0. And then solve for x where needed. And so we need to solve for x on these two. This one's already done. X cannot equal -2 and x cannot equal +2. Also, x cannot equal 0. So my three restrictions are x cannot equal 0, -2, or +2. All right, step 2, recall, is to factor the numerator. So I'm going to factor the numerator. And so that gives me, I need something that multiplies to +36 and adds to 2. And so what values will multiply to 36 and add to 2? Oh, it should be 20. I was going to say nothing will. 20. I had a typo there, right? It should be 20x. Oh, my bad. All right, so 20. That's a little better. All right, 18 times 2 will do that. 18 and 2. And so we're going to factor by grouping. That's x squared plus 18x plus 2x plus 36. We're going to take out the GCF of each side. So the GCF here is x, and that gives me x plus 18. The GCF here is 2, and that gives me x plus 18. And then we're going to take out our common factor again and group our leftovers. There's my numerator, and then step 3. Well, actually, we're going to write it over our denominator, which is this right here. Our denominator was x plus 2, and x minus 2. And then the step 3 is to divide out common factors. And so common factors in this case would be, we have in the numerator an x plus 2 and in the denominator an x plus 2. And so that leaves me with x plus 18 over x times x minus 2. And x cannot equal 0, -2, or 2. All right, for B, let's go ahead and do B. We have x squared minus 2x minus 15 over 2x squared plus 3x minus 9. All right, step 1. We're going to factor the denominator, right? Say it cannot equal 0 and factor it and see what will do that. So we need something that multiplies to a times c, 2 times -9 is -18, and adds to b, which is 3. Those numbers would be 6 and -3. And so my denominator factors by grouping, we're going to do 2x squared plus 6x minus 3x minus 9, that cannot equal 0. Factor by grouping, so take out the GCF. The GCF here is 2x, that gives me x plus 3. Don't forget, bring the negative sign straight down. The GCF is 3. That gives me x plus 3 again. Watch your signs here. And then we're going to factor by grouping again. We'll take out the x plus 3 and group the leftovers together. Now we'll apply that zero product property. So x plus 3 cannot equal 0. 2x minus 3 cannot equal 0. X cannot equal negative 3. Here I have to add the 3. That gives me 2x cannot equal 3, and then divide by 2. X cannot equal 3 over 2. And those are my two restrictions. All right, next we're going to factor the numerator. So step 2 is to factor x squared minus 2x minus 15. And so this factors as what will multiply to negative 15 and add to negative 2. And that would be 5 times negative 5 times 3. So I'll split my middle term. That's minus 5x plus 3x and then minus 15. Split it and take out the GCF of each half. That's x minus 5 plus 3, x minus 5, and then group my leftovers. All right, I'm going to write that over my divisor. My divisor is right here, which was x plus 3 and 2x minus 3, and then take out any common factors. So the common factors are x plus 3. So we're left with x minus 5 over 2x minus 3, and x cannot equal negative 3 or 3/2. All right, and finally the try these C. This one's a little different because we have a little bit of a switch up with the denominator. X cubed minus 9x over 3 minus x. I want you to understand 3 minus x is not the same as x minus 3, but 3 minus x is the same as negative 1 times x minus 3, and I'll show you why that is. If you were to multiply this through, you're going to get negative x and then plus 3, which is the same as 3 minus x, right? The negative x, and positive 3. We don't write it, but positive 3. Okay, so that's a little trick that you might need to have in your toolbox. So we're going to take the denominator. We're going to do step 1, right? This cannot equal, negative x plus 3 cannot equal 0. You notice all I did was switch the terms around. And so negative x cannot equal negative 3. X cannot equal 3. That is the only restriction. All right, now we're going to factor the numerator, so that's step 2. First, I'm going to take out any common factors. There is a common factor. It's x, and that gives me x minus 9. X squared, sorry, minus 9. And then this is a difference of squares, so this factors as x plus 3, x minus 3. There's my numerator. I'll put it over my denominator. Remember, my denominator is this guy right here. Negative, and then x plus 3. Now, if I factor out a negative, I will be able to cancel something out. So as it stands right now, nothing reduces. So there was my step 2, right, factor. I'm going to go ahead and take a negative out of this. If I take a negative out, I will have negative 1 times x minus 3. If I multiply this negative through, I will end up with this expression. And so now these will reduce. And so that's step 3. We're reducing the common factors. And so I have x times x plus 3 all over negative 1. I'm going to rewrite that. I can pull that negative out front and leave, we don't even need to have the 1 in the denominator. And then don't forget to put your restrictions. X cannot equal x cannot equal positive 3. All right, so hopefully you got those correct. You guys should try to check your understanding. I'm going to just go through it really quickly. It says you're given a rational expression and told the expression must be restricted so that x cannot equal 3 or negative 3. What is the denominator of the expression that you were given? Well, if x cannot equal 3 or negative 3, that means that your factors were negative x minus 3 and x plus 3, which means that this was x squared minus 9. All right, multiplying rational expressions. So now we're moving on to multiplying rational expressions. Oh, I should do number 2 actually. So it says construct viable arguments. Is it possible for a rational expression to have no restrictions? If so, give an example. Sure. What if you don't have you have whatever you want in the numerator, we don't care. What if in the denominator there's no x, like just a 2? So sure, and this could be x plus 2 over 2. That's still a rational expression. Okay, so to multiply rational expressions, it says first factor the numerator and denominator and then divide out common factors, and then go ahead and do your multiplication, okay? And don't forget that you still have to check for restrictions on the denominator. So let's go ahead and do these examples off to the side. All right, so we've got the original expression is, so this is example B, 2x squared minus 8 over x squared minus 1 times x squared plus 2x plus 1 over x cubed minus x squared minus 2x. All right, so to remind you of step 1, we're going to take these denominators and set each one. Now we're going to have to do this twice, right? Once for the left fraction and once for the right fraction. So we're going to take both of these and we're going to say they cannot equal 0. And then we're going to solve them. So this one factors, it's a difference of squares as x plus 1, x minus 1, and that cannot equal 0. So that means that x plus 1 cannot equal 0, and x minus 1 cannot equal 0. And so x cannot equal negative 1, x cannot equal 1. All right, on this side, we're going to go ahead and take out the GCF first. So we take out an x, that gives me x squared minus x minus 2. That cannot equal 0. And then this factors further. Something that multiplies to negative 2 and adds to negative 1 would be negative 2 times 1. So don't forget to bring that x straight down. This is going to be x squared minus 2x plus 1x minus 2. And don't forget to bring the x down. Factor by grouping, we're going to take out that GCF. The GCF here is x. That gives me x minus 2. The GCF here is just a 1. That gives me x minus 2. Don't forget to bring down your x. Take out the GCF again. That's x minus 2, x plus 1. And bring down your x. Now apply that zero product property where all of these cannot equal 0. So x cannot equal 0, x minus 2 cannot equal 0, x plus 1 cannot equal 0. So our restrictions are, on this fraction, x cannot equal 2, x cannot equal negative 1. Oops, negative 1. And x cannot equal 0. So here are our 5 restrictions. 1, 2, 3, 4, 5. But this one is really a repeat of this one. So really there's only 4 restrictions. All right, next we're going to rewrite our numerators. So step 2 is to factor the numerators. Let's go ahead and do that. So here I'm going to take out the GCF, which is 2. That gives me x squared minus 4. And then this is a difference of squares. So this is going to factor as 2x plus 2 and x minus 2. All right, this one, I need something that multiplies to 1 and adds to 2, like 1 and 1. And so that would be x squared plus 1x plus 1x plus 1. I'll split it and take out the GCF. The GCF there is x. That gives me x plus 1. The GCF here is 1. That gives me x plus 1. And then I get x plus 1 times x plus 1. All right, so there's my numerators. Here are my corresponding denominators. So I'm going to go ahead and write those in fractions. So here we've got 2x plus 2, x minus 2 over this denominator right here, x plus 1, x minus 1, times this guy, x plus 1 times x plus 1, over this denominator right here, which is x, x minus 2, and x plus 1. All right, if there's anything in common, it's easier to reduce it now. So these x minus 2's can cancel, these x plus 1's can cancel, these x plus 1's can cancel, and you see that over here, all that's left is an x, and all that's left here is a 2, x plus 2, and then an x minus 1. Oh, I forgot my parenthesis there. And so our final answer would be 2x plus 2 over x minus 1 times x. And there we go. And so you can see, right, that that's the same answer that they got right here. they did state their restrictions. Let's go ahead and put that. X cannot equal 0, 2, -1, and 1. And we already have a -1, so we don't need to write it again. All right, I'm going to stop right here because the video is getting to about that point. I hope that you have so far understood. Dividing will be the same thing, only that we will multiply by the reciprocal, and I'll see you on the next video.